This video is going to be describing significant figures, how to determine sig figs in a number, and also how to write an answer of a calculation using sig figs. So sig figs, I understand that for undergrads, sig figs often seem to be very tedious and frustrating and, quite frankly, annoying. And they seem to be, and sometimes could question even the point of them. But remember, scientists are very, very, very careful about what we say and what we mean. The words and the language that we use. Scientists have to be very, very particular, and that goes with our numbers as well. I'm sure you've heard of, basically I'm sure you've heard of the phrase, "You're only as strong as your weakest link." Well, you can only be as accurate as your least accurate measurement in science. And that's where sig figs come into play. So, before I start talking about rules of sig figs, I want to first describe the difference between two terms: precision versus accuracy. A lot of times people use these two interchangeably, but they do not mean the same thing. Right? So precision, that tells you how close your measurements are to one another. Measurements are to each other. And accuracy is how close your measurements are to the actual value. How close to actual value. And the most common depiction of this that you'll see is with a dartboard. So let's say we have a dartboard here. I'm not gonna draw out all the triangles and everything, but you get the picture. So you throw 3 darts, and you're trying to hit the bullseye. Let's say you hit the bullseye on one, and the other one goes here, and one goes here. Well, the average position of those would actually fall right on the bullseye. So the average position is extremely accurate. You hit your mark. However, none of them really hit the same part of the dartboard. I guess I could have drawn them further apart to really exemplify that, but you see, they all kind of hit different areas of the dartboard. So they were not precise. Your measurements were not close to each other. I guess here, let me throw a couple extra out there. Still, the average of these is about right in the middle, but you can see that there's a wide range of, measurements per se, or where the darts hit, right? So these were not precise, but they were accurate. Let's say somebody else throws darts, and again, they're aiming at the bullseye, and they miss horribly. But they put all 3 of their darts right next to each other, way up here. So they were absolutely not accurate, because they were going for the bullseye and they weren't even close. But they were extremely precise, because all of their measurements, or darts in this case, were very close to one another. Does that make sense? And of course, if you group all of them right at the bullseye, that would be both precise and accurate. And if you just have complete randomness all over, that could be neither precise nor accurate. Okay, so determining sig figs. So there's a couple rules for determining sig figs within a number. So the first rule, all non-zero digits are significant. All non-zeros are significant. Always. So basically, anything that is not a zero is going to be significant. The one exception is in scientific notation. So in scientific notation, you always have some kind of number, I'll just say 6 for right now, times 10 to the something, right? This whole region here, the 10 with the exponent, that part does not count in sig figs, no matter what, right? So for sig figs, it's always just that region in there for scientific notation. Alright, next rule is all leading zeros are not significant. So leading zeros, not significant. What does that mean? Well, a leading zero is just any zero before your first non-zero digit. So let's say we have 0.005. left to right, the first non-zero digit is this 5. So any 0 before that is not significant, no matter what. You don't start counting sig figs until you hit your first non-zero number. The next rule is trailing zeros. Trailing zeros are significant if a decimal exists. So if a decimal is seen in the number, then trailing zeros, which are zeros after your last non-zero digit, are significant. So of course if I threw a 0 on there, that's a trailing 0 because it's after your last non-zero number. So that is significant because this decimal is seen right there. But let's say we even have 500 written like this. So just like that, if you do not see a decimal on the paper, those trailing zeros are not significant. If I even so much as do that and put a decimal there, even though there's nothing after that decimal, those are significant now with that decimal present. And I know that seems odd, but that's because this and this, scientifically speaking, there's a big difference here. What this means is that basically, to the best we know, it's around 500, but that 5 is the last digit that we can be certain of. This is saying up all the way up to that ones place, we know for a fact it is 500. Does that make sense? I hope so. Okay, and the last rule for determining sig figs in a number is that any middle zeros are significant. So those are just zeros between two non-zero digits. So something like this, 505. That would make it significant, whether there's a decimal present or not. Right? Now, I'm talking about multiplication and division and addition and subtraction, and rules for sig figs when doing calculations. So multiplication and division use the same rule as each other. And what that rule is that the answer has the same number of sig figs. I'll just say SF for sig figs for the sake of time right now. Has the same number of sig figs as the least significant number used. What does that mean? Well, so let's say we have 15 down here. 15 times 100. I'm going to put a decimal there on that 100. So the 15 has 2 sig figs, the 1 and the 5. And because that decimal is there, this 100 has 3 sig figs. All 3 of them are significant because it's a non-zero digit and 2 trailing zeros. So the numbers that you're multiplying have 2 sig figs and 3 sig figs. That means that the least, or I guess the lowest number of sig figs out of any of the numbers you're using is 2. The 15 has 2 sig figs, right? So that means that your answer can only have 2 sig figs. So when you write it out, you'd say 1500 with no decimal, because it can only have 2 sig figs, and it would be the 1 and the 5 here. So again, that's kind of what I mean by you're only as certain as your least certain number. Right? With I will say there are a couple exceptions, and these exceptions will make more sense as you see more problems, but there are things called conversion factors, and any conversion factors or known exact values, or any like counting figures. Well, if you were to say there are 3 people in this room, anything like that you will not be using when determining sig figs, and again, that will make more sense when we start talking about the last video of this chapter, and you'll start to see more about what conversion factors really are. And then the last thing for this video is addition and subtraction, because the rule is a little bit different for these. So addition and subtraction. For this one, your answer is as certain as your least certain decimal used. As least certain decimal used. So what does that mean? Well, let's say we're going to add, so we'll do 5.55 plus 6.5. If you just add this up on a calculator, you would get an answer of 12.05 and call it good. However, when looking at these, this first number, 5.55, it goes to the hundredths place, right? It goes 2 spots after the decimal. 6.5 only goes to the ones place. It only goes, oh, sorry, not the ones place, the tenths place. So it only goes 1 spot after the decimal. So that means that the least certain decimal used is basically the one that goes the least distance past the decimal, right? So the tenths place here is going to be your least certain, because that's less certain than a hundredths place. So that means that your answer can only go to the tenths place, whatever your least certain decimal place is out of all of the numbers you use. So we have to take this and round it to the tenths place, so we would round it to 12.1. And the reason why is because if we're saying 12.05 is our number, that basically, scientifically speaking, that means that we are implying that we know for a fact that the hundredths place in this 6.5 number is a 0. But here, as you can clearly see, we don't actually know that. Based on the measurement that got us this number, we were only able to get a number to the tenths place. So we can't definitively say this is 0.05. The only thing we can say is it's approximately 12.1 based on the data and measurements we have. And those are sig figs.